All right, welcome back to A212. We are starting to wind down here, getting to the end. There's a few chapters left, and I think you'll be very pleased to know that today is a very short lecture, very short chapter. Within Chapter 23, we're going to be covering standard cost systems. So we're not going to be covering every page in Chapter 23. And what we're going to be doing is really looking at variances today. Variances is one of those topics that students usually like because it's very mathematical. If you're a black and white person, this is very black and white. Some number crunching, but not too bad. And basically what we're going to be doing is variance is really just looking at what's the difference between what the company had budgeted versus what the actual results are. Okay? So let's just dive into the material. So first thing we'll talk about is what standard costing is. So when companies are trying to forecast their budgets, they use standard cost. Very similar to how if you're trying to forecast your own grocery bill every month. You may sit down and think, all right, gallon milk is going to cost me this, meat will cost me this, bread will cost me this, and you're going to do that based on what you expect to pay for your groceries. The same thing with a company. They have an idea of what they're going to be paying for the materials, the labor, etc. And this is what a standard cost is. A company has set what they believe they will pay for materials, what they believe they will pay for labor hours. In addition, they also have a standard set for what they believe they will use in regards to labor hours and material. And that's what standard costing is. So why does a company even do this? Why do you even sit down and say, all right, my mom's like the queen of this. She makes her grocery list, she sits down and says, okay, I'm going to be spending this XYZ dollars today when I go to the grocery store, because she has a standard cost in her head. She knows what she's expecting to pay. Now when she gets there, right, it could be more or less, but she has a standard set in her mind. So why would a company want to do this? Well, it helps in planning operations, and it gives insight into the probable impact of managerial decisions. Uses of standard costing is to a big one. Establish budgets, right? We can't establish a budget if we don't know what we're expecting to pay for something. To control cost and maybe motivation to maybe decrease cost, which is moving right into promoting possible cost reduction. In addition, especially if you are on the government side, the standard costing is going to be important for establishing bids and contracts, and if you're going to set sales prices. So how are these standards developed? How does my mom know what she's expecting to pay for her gallon of milk? Well, this is typically the hardest part, okay, especially for a company. Basically, they really need to gather as much information as possible and use as much coordination and communication among the different divisions. So a big part when they're trying to set standards, they're going to use external sources. So for example, in 2006 and 2007, gas prices were really starting to go up there. They had to use external sources to say, okay, what are we predicting gas prices are going to do, and how is that going to impact grocery prices? How is that going to impact our purchases, etc. They got to use some engineering studies. And the big thing is they got to use employee input. The production manager, what are we expecting to use for labor time, the amount of labor we're going to use. So when we're looking at standards, we're not just looking at the dollar value we're expecting to pay for labor and for materials, we're also looking at how much are we expecting to use. And a lot of times that goes right back to talking with the horse's mouth, the people that's on the floor that knows the day in and day out business of what they're doing, to say, what's your thoughts? Do you think we'll be able to speed up the processing here, or is it going to take longer, etc.? There's two types of standards out there. There's ideal standards and attainable standards. Ideal standards would be what would be the price we would pay and what would be the amount we would use if we worked in a perfect world. If every employee came to work ready to go, putting their best employee output out there, if every machine never broke down, if every time we talked with the supplier they said, guess what, we're going to give you a good price today, or guess what, we're not increasing our prices this year, that's the ideal standard. Typically, right, we do not live in this type of a world. So most companies use attainable standards. They factor in things such as we may have an employee coming in today that has a hangover and is not going to give us our best job. Or what happens if the minimum wage goes up and we need to bump up our salaries as well. Or gas prices go through the roof. So hey, guess what? Our materials are going to go increase because we have to pay for that. So basically, they're going to allow for an imperfect world. So putting these standards to use. So these standards really come into play when we're going to be talking about variance analysis. And remember, variance analysis is really just comparing the budgeted to actual results. So there's two types of variances we're going to be looking at. We're going to be looking at price or rate variances. We're going to be comparing the price paid for materials or comparing the price paid for labor versus what we had expected to pay, which is the standard prices, okay? And then the other type is the usage efficiency variances. We're going to be comparing the quantity of materials and labor used versus what we had expected to use. So now we're going to be looking at the 4 variances that you will become an expert in calculating. We're going to just talk about what each variance is going to tell us, the formula, and who would be responsible within the factory for that variance. And then what we will do is put these variances into play. So the first one is the materials price variance, which is going to show us the difference between what is paid for the quantity a material versus what we should have paid. The formula is the following. It's the AQ, and let's just put some definitions down. AQ is the actual quantity purchased. AP is the actual price paid. And SP is the standard price paid. So let's have that little key for us. So the formula is going to be the actual quantity that we purchased times the actual price that we paid minus the actual quantity that we purchased times the standard price. So the standard price being what we had expected to pay. Now, right within formulas, there's another version of this, and I believe your textbook shows you another version of this formula. You're more than welcome to use either version of it. For some reason, this version clicks in my mind better, and for me, I can more analyze it. However, some students like the version the book gives you, so whatever floats your boat. All right? And who would be responsible for this price variance, good or bad, is going to be the purchasing manager. Then we have the materials quantity variance, okay? So materials price variance, we're focusing on what we paid. Material quantity variance, we're focusing on the amount, the quantity of the material that we use versus what we had expected to use. So for this formula, our AQ is going to equal the quantity used. So not necessarily the same as the AQ up here. The SQ is the standard quantity used, what we had predicted we were going to use, and SP is the standard price. So we're going to take the actual quantity we used times the standard price minus the standard quantity we had expected to use times the standard price. And the responsibility of this variance would be the production manager. Then we have the labor rate variance, which is we're going to be looking at the difference between what we actually paid our employees versus what we had expected to pay. And for this formula, we're going to be looking at the following. We're going to use something called AH, which is the actual hours worked, times something called AP, which is the actual price that we paid, and SP still stands for the standard price that we paid. So our formula for this would be we're going to take our actual hours that we worked times the actual price minus the actual hours that we worked times the standard price, what we had expected to pay. And the person responsible for this variance would be human resources. It could also be blamed on unions, if you have a union and maybe a new contract put into effect, market conditions, etc. And then the final variance we're going to look at is labor efficiency variance, where we're going to be comparing now, up above we compared how much we paid. Now we're going to be comparing the amount of hours that we used in production versus what we had expected to use. And that formula is the actual hours that we worked times the standard price minus the standard hours that we should have worked times the standard price. And the responsibility for the efficiency variance would lie with the production manager. So now let's look at this a little bit differently. Here's another way to look at the variances. If you don't, you're thinking, great, I have to memorize 4 formulas. Not necessarily. Basically, these 2 formulas will give you the price variance and the rate variance. So this would give us the direct material variance, and this would give us the direct labor rate variance, while these 2 formulas will give us the direct material quantity variance and the direct labor efficiency variance. So really you just got to memorize these 3 items and know that this times this gives us these 2 variances, while this times this gives us these 2. So when we're comparing the variances, we're not going to show if it's a positive or negative number. What we're going to show if it's a favorable variance or an unfavorable variance. So a favorable variance, if the actual number was less than what we had expected, the standard, we're going to indicate that with an F. Now, even though we're saying it's a favorable variance, that doesn't necessarily mean it's a good thing or it's a positive thing. And we'll talk about that a little bit more detail here in a few minutes. If it's unfavorable, we're going to say that would mean the actual results. The actual was greater than what we had expected, and we're going to demonstrate that with a U. But once again, it doesn't necessarily mean it's a negative thing. And either variances, we're never going to indicate there's a negative sign or a positive sign. We indicate it instead with an F or a U. So let's look at an example. Here we have Zions Incorporated uses a standard cost system in which direct materials inventory is carried at standard cost. Zions Incorporated has established the following standards for the cost of run product. So this is their standard cost right here. Let's just highlight that. So they're expecting to use 3 pounds of material for every product, and they're expecting to pay $3.60 per pound of material. They're expecting to use 1.25 hours for every product, and they're expecting to pay $10 per hour. So this is their standard cost. It says during June, Zions purchased 75,000 pounds of direct materials for $3.80 per pound. The total factory direct labor wages for June were $327,600. Zions manufactured 22,000 units of product during June, using 68,000 pounds of direct material and 28,000 direct labor hours. So this paragraph here that I'm going to highlight in yellow is all actual data. This is standard data, this is actual. So for the 4 variances we discussed earlier, we want to calculate the direct material price variance, direct material quantity, direct labor, and direct labor. We want to compute the dollar amount of each variance and say if it's favorable or unfavorable. Then we want to talk about possible reasons for why we may have the variance. And then finally end with identify who might be held accountable for the variance. So let's begin, shall we? See if I can get this to look a little bit prettier. I don't like that. I don't like that either. There we go. That's what I was looking for. Alrighty. So looking at the direct material price variance, first thing we're going to do is put in the formula. So direct material price variance, we're going to look at the actual quantity that we purchased times the actual price minus the actual quantity that we purchased times the standard price. So the first thing we want to look at is the actual quantity that they purchased. So it tells us here, so we're going to look in the yellow area, that they purchased 75,000 pounds of material. The AP is the actual price. So again, we're looking at the yellow paragraph because we're looking for actual data, is $3.80. Then we're going to take the second part of the equation of AQ, so still the 75,000 pounds, times the standard price. So times SP, we're looking up here in the blue area, the standard price of $3.60. And if I do the math, this comes out to $15,000. But how did I already know it's U, it's unfavorable? Well, basically, what we're doing here is we're comparing the price of $3.80, the actual price, to the standard price. So if I compare the $3.80 to the standard, we paid more than what we had expected. So if we pay more than what you had expected, that's unfavorable. So why could be some reasons why they paid more? Well, maybe they end up purchasing a higher quality of material than they had planned. Maybe there's some external forces into play, such as gas prices went up, or that type of material has came more into demand. So, demand supply, the price went up, etc. And then who would be responsible or held accountable? It would be the purchasing manager. Now let's look at the direct material quantity variance. So the formula for this is AQ, the actual quantity used, times the standard price minus the standard quantity we had expected to use times the standard price. So here, direct material quantity variance, remember we're comparing now the quantity used, not how much we paid for the material, but how much we used of it. So AQ, actual quantity, so we're going to look to see how much quantity they used, which up here it tells us 68,000 pounds. Then we're going to times that by the standard price, which is up here in the blue, $3.60. Then we have to calculate how much have they expected to use. And I'm thinking, you're like, where did she get that? $66,000. I don't see that anywhere. Well, I had to calculate it. They tell us up here in the standard area, they expect to use 3 pounds of material for every product. So I know they're going to use 3 pounds of material for every product. And they made 22,000 units. So based on what we had expected, if they made 22,000 units, they should have only used 66,000 pounds. So that's how I got my SQ. And then I would times that still by the standard price of $3.60. And if you do that, you get $7,200. And how do I know it's unfavorable? I'm now comparing the quantity that we used versus what we had expected to use. So we used 68,000 pounds of material. We had only expected to use 66,000 pounds. So we used more than what we had expected, so that's unfavorable. So what could be some reasons why it's unfavorable? Well, maybe we had a lower quality of material. Maybe we had machine breaks down where they was eating the material. Maybe we just had some human error. There's very possible reasons. And the person that would be held accountable would be the production manager. All right, so we got 2 of the 4 variances done. Now let's look at the direct labor rate variance. So the direct labor rate variance is comparing how much we paid versus what we had expected to pay. So it would be the actual hours times the actual price minus the actual hours times the standard price. So actual hours, how many hours did they work? Well, it tells us up here that, because we want actual data, so we gotta look at the yellow, that they worked 28,000 hours. Times the actual price. Nothing up here tells us how much they're paying their employees per hour. But I can back into it, because it tells us that their total factory wages were $327,600, correct? And it tells us that they worked an actual of 28,000 labor hours. So if I take the total cost divided by the labor hours, I can back into that they're paying their employees $11.70 per hour. Once again, what I did, I know that the total factory direct labor wages were $327,600. And I also know that they worked a total of 28,000 hours. So if I take the total cost divided by the total hours, I can back into that they paid $11.70 per hour. So that would be my AP. Then I'm going to subtract the actual hours at 28,000 times the standard price of $10 per hour. And that standard price of $10 per hour is coming up here in the blue area. And if I work that formula through, I get 47,600, which is unfavorable. Why is it unfavorable? Because we're comparing the rates. They paid $11.70 when they had only expected to pay $10. So they paid more than what they had expected, so that's unfavorable. So what could be some possible reasons? Well, maybe they hire more skilled workers. Maybe there was a union contract that increased the wages. Maybe there were some external forces into play, such as increasing minimum wages, etc. And who would be held responsible? Primarily the HR manager. Then finally, we're going to look at the direct labor efficiency variance. We're going to look at the actual hours worked times the standard price minus the standard hours times the standard price. So let's go up above. We know they worked, the actual hours worked were 28,000. And our standard price that they're expecting to pay is $10 per hour. Then we're going to subtract that by the standard hours. How many hours should they have worked? Well, we kind of have to calculate this number. They had planned that they need 1.25 hours for every product. And they made 22,000 products. So if they would have used only 1.25 hours for every product and would have made 22,000, they should have only used 27,500 hours. So that's how my SH I calculated. So let's look at that one more time. How did I get that 27,500? They had planned on only using 1.25 hours for every product. And then they made 22,000 products. So they should have only used, based on their budget, 27,500 hours. And if I calculate this through, I get $5,000. Now, how do I know it's unfavorable? Well, I'm comparing the hours used. They used 28,000 hours when they had expected to use 27,500. And that's how I get the 5,000 unfavorable. So why do we maybe use more hours than we had expected? Well, maybe we had some untrained workers. Maybe we had some poor quality of material that took longer to make the product, etc. And the person held responsible would be the production manager. So now we've taken a look at one example of variances. Let's take a look at another one to give you guys some extra practice. So the next problem we have is Brassy Tunes Incorporated manufactures brass musical instruments. Brassy Tunes Tax Division, located in Hornville, Montana, manufactures trumpets. The production process consists of several steps. Well, we don't need to really read through that, do we? Below are the standards for the production of one trumpet. So once again, I'm going to highlight this in blue. So they're expecting to use 10 pounds of material per trumpet, and they're expecting to pay $7 per pound. For labor, they're expecting to use 5 hours per trumpet, and they're expecting to pay $20 per labor hour. Below is the actual information for the month of October. So let's highlight that in yellow just to stay consistent with our colors. So they actually end up purchasing 45,000 pounds at $7.10 per pound. They used 20,500 pounds. They worked 9,800 hours at $21 per hour, and they produced 2,000 trumpets. And we want to compute the 4 variances that we have previously discussed. So let's look at the direct material price variance first. We're going to look at the actual quantity purchased times the actual price. Sorry, I was trying to get this. Minus the actual quantity purchased times the standard price. So actual quantity information, we're going to look at the yellow. So they purchased 45,000 pounds at the actual price of $7.10. Then we're going to subtract the actual quantity purchased, the 45,000 pounds, at the standard price, which is here at $7 per pound. And if we do the math, we come out to 4,500. Now, how do I know if that's favorable or unfavorable? Well, we're comparing the prices that we paid. So we paid $7.10 when we had expected to pay $7. So since we paid more than what we had expected, this would be an unfavorable variance. All right, let's look at the next one. Let's compute the direct material quantity variance. So here we're going to be looking at the actual quantity that we used times the standard price minus the expected quantity we had expected to use when making the trumpets times the standard price. So the AQ is the actual quantity of material we used, not what we purchased. So that would be the 20,500 pounds. Then we're going to take that times the standard price of $7 per pound minus the 20,000, the standard quantity that we had expected to use. So how did I get that 20,000? Well, it tells us here that they expect to use 10 pounds for every trumpet that they make. So if they expect to use 10 pounds for every trumpet that they made, and they ended up making 2,000 trumpets, we should have only used 20,000 pounds. And we would times that by the $7. So here we're comparing the pounds that we used versus what we had expected to use. And if we do the math, it comes out to $3,500, and that's unfavorable because we used more than what we had expected. Now let's look at the direct labor rate variance, where we're going to look at the actual hours worked times the actual price minus the actual hours worked times the standard price. So the actual hours worked, it says here, is 9,800 hours. And then we're going to times that by the actual price of $21 an hour. And then we're going to take the actual hours worked of 9,800 times the $20 per hour that we had expected to pay, that I get up here in the standard information. And here we're comparing with the direct labor rate variance, the price, the amount we're paying per hour. So it comes out to 9,800. How do I know if it's favorable or unfavorable? Well, we paid more than what we had expected, so it's unfavorable. All right, let's wrap this bad boy up with the final one. Compute the direct labor efficiency variance. So here we're looking at the actual hours worked times the standard price minus the standard hours, what we should have worked, times the standard price. So the actual hours worked is 9,800 hours given to us in the actual data, times the standard price of $20 per hour, minus the 10,000 hours. How did I know they should have only worked 10,000 hours? Well, we know they're supposed to work 5 hours per trumpet times the 2,000 trumpets they produce, so they should have worked 10,000 hours times the $20. So in this one, because we're looking at the efficiency or the usage variance, is going to be, we're comparing the hours used. So it comes out to 4,000, but this time around we used less hours than what we had expected, so that would be a favorable variance. All right, my friends, that wraps up this lecture. I told you it was short and sweet and not very painful. The attendance phrase for this week is Scooby-Doo, just because it makes me smile and brings back good memories of childhood. Hope you have a great week. Please let me know if you have any questions or concerns. Thank you.